Okay, hello everybody and welcome to my very first tutorial creating a procedural crystal system inside Houdini. My name is Jaron Wilding and I will guide you through the entire process of creating this system from scratch, where you can just select your paint tool, select it here, let's reset the changes, hit enter, and let's draw out a system. Here, I'm probably going to go like that. I'm going to hit escape, and then if we go all the way down to the bottom here, and we select our gem cache, and we're going to hit save to disk, because I'm just going to reset my gem cache because this one was saved out previously, and I want to show you the updated version. Now I did record this tutorial before, but it went for about 2 hours, so hopefully I'm going to be a bit faster this time. I've got it more mapped out. I've even updated the whole system, as there were some slow points in it that just made the overall system slow. It is still pretty slow now, but this is as fast as I can get to it currently. There was an error in my last system where the points would jump from one point to another point incorrectly, so it had a lot of skewing going on around where the gems should be growing from. So I've managed to fix that now using some attribute wrangles, and hopefully we shall be able to recreate this system fully today in at least under 2 hours. So there we go. There's my procedural growth system all working properly. Okay, so I'm going to have this off to the one side so that I can refer to it in case I've made any changes. You can see that I also, for continuity's sake, I use nulls in green to indicate markers for myself. I also use net boxes, but only for areas that require it. These areas not so much, because they're for each loops. Now I am going to go into for each loops quite a bit, because this is what this tutorial mainly heavily relies on. If you don't know much about for each loops, then this tutorial is definitely for you, because I've shown my method of how to iterate over every single polygon or every single group in ordered and proper way. There are going to be some points that I'm going to talk about as well, but I'm going to be using a pen tool, and I'm going to be drawing out what I'm going to be saying so that you'll all understand and be able to follow along. Now, I'm not going to show you how to render out this system. That's up to you. I suggest using the entanglement tutorials. They're quite good, especially the crystal one they have, where they show how to render it all. You can use these crystals in that system. However, what I would suggest is iterating over every single crystal separately, and maybe even converting them into an ISO offset, and then converting them back into a polygon, because I found, when I did try that, I found some errors within the system overall, and it would make some really bad VDBs. Okay, so let's get into it. So first of all, let's load up a Houdini scene. I'm just going to start by saving this out into my not there, into my Houdini projects folder, which is down here somewhere. Here it is. And so I'm going to be calling this crystal system.hip. Okay. Oh well, .hip lc, because I'm using the indie version. Okay, so the first thing we're going to do is we're going to lay down a geo, and then going to the geo. For continuity's sake, let's just rename this to crystal. We are going to be doing this all in one node, so that's fine, but you don't need to rename it, but I find this easier. So then we're going to lay down what we're going to be painting on. I'm going to use a grid for this system, mainly because it's easier to draw on, and we don't need to create like a full-on cave and stuff, so that everyone can see how the crystal works. This will work in a cave system. You can even make this into a OTL or HDA or whatever it's called. I can't remember. I believe I call them OTLs. So for starting out, I'm just going to use 4x4, and then I'm going to copy this parameter, paste it into there. I'm then going to say times 10, so that we get a lot of polygons to work with. And then I'm just going to copy this parameter and paste it into there. If you don't know what that means, then I suggest looking at the side effects, Introduction to Houdini tutorials. So I'm just going to make this my base. Let's just go to my other one to make sure that I'm following the right path. Now, for this system, I use the paint tool, but when you just lay down a paint sop, it can throw some very nasty errors. What normally people will do is they'd say apply to all, and then go to the foreground, hit enter, and then paint over like that. I found this doesn't work as often as I'd like it to. So what I tend to do is I lay down a color node first, and then I change it all to black from there. This just makes it a lot easier for be able to use. Now I'm going to be using point for this, but we are going to promote it up into the primitive level later on. Okay, this is just so that we can get more art directability in this. Also, I'm going to go into my normal lighting here, right click, and disable specular, so I don't get any of those specular highlights in there mucking up my viewport. Okay, so then I'm going to lay down my paint node. And then what I do is I don't have to touch anything of this, I just hit enter on my main screen. I will hit shift and middle mouse to make my paintbrush larger, and I'm just going to paint an area here. Maybe not as big, so I'm just going to do like one here like this. I'm trying my best to make it appropriate for the internet. Okay, there we go, just a blob. Okay, and then I hit escape, and now it's all saved in there. Okay, now we want to promote this up to the primitive level. The reason we're doing this is because we're going to be using a primitive wrangle. So let's go promote, attribute promote, and then we're going to say from CD, which stands for color, from original class, from point to primitive. And there we go. You see how it's evened them out a lot more. So it's not going from point, oh, here's point, this point's going to be 1, this is going to be 0. It's actually evening it out a lot more. Okay, then we say primitive. Not many people like to use primitive nodes. I do because they're just useful. They're there, why not use them? Okay, so I then do translation, and I'm just going to be using the group, I'm just going to be using the expression $CR, which stands for color red, or the color channel red, times 0.05. Now the reason I do that is because everything that has a value of more than 1 or more than 0 in the channel red will be pushed up by 1, but then I say I don't want it to be that far, so I'm going to times that by 0.05 to bring it back down. So it's just extruding it up a little bit. It's not even extruding, it's just pushing the points up a little bit more. We could use a transform node, but this is a simpler method for me. Okay, now we're going to want to group these, or to be more specific, we're going to group them, but before we group them, we want to do a contrast effect on them, so we're not capturing everything. So what I'm going to do is I'm going to lay down an attribute wrangle. Okay, now I'm going to type in my vex, I'm going to type in at cd.x equals fit at cd.x. So we're getting this, we're fitting the CD, the already CDX, with a channel user A and a channel user B. I'm just going to rename that a bit better, as well as put that into its own brackets, so we're not throwing any errors. 0, 1, 1. There we go. End brackets. There we go. Okay, hit enter, or click out of it. You see what's happened here? It's made the color red, or X, because X equals red in Houdini, because we're using vector, because a color is a vector, and a position is a vector, so XYZ is a vector, RGB is a vector, we can use those two methods. I'm then just going to copy and paste that twice, and I'm going to change this to Z, and this one to Y, this one to Y, and this one to Z. Okay, there we go. Now we're back to a bit more grayscale point. But it's done nothing. So we're just going to hit this little node which creates all the channel references that we've made. So I'm going to push this up to about 0.499 and this to 0.5. And it's done nothing. So why has it done nothing? What it should be doing is it should be doing a contrast effect. It doesn't seem to be wanting to do a contrast effect. Oh my. So let's go back to here, see what's happening. All the channels are there, yes. User A, user B. Okay, then I'm not even going to use the channels then because this doesn't seem to be working. So I'm going to just try putting in 0.499. See what happens there. Okay, 0.5. Nothing's happening. What it should be doing... Oh, I see my problem. Okay, so I'm just going to change this back to there. This is a good example of why we should always, when we start putting down wrangles, we should make sure what we're going to be iterating over. Because the CD is now in the primitives section, we should be running over the primitives. And there we go. That's fixed my small little error that I just was throwing there. So I'm going to put this down to 0.5 again, 499, and so now I've made a contrast effect. Okay, now we want to group these. Now, we could just lay down a group node, but because we're already in Vex, let's just do it in Vex. So, I'm going to say if at cd.r or x is less than, or, oh, wait, yes, less than 1, then tab I, group to delete equals 1. Close the if statement, hit Control Enter, and then if we go and right middle mouse click on this thing, we go on the node, we're going to see that we're now in we've grouped 1,301 polygons. So is this correct? Yes, it is. Okay. Next, what we're going to do is you could put these nodes up before you've even put in the paint node and stuff. I choose to do it this way. So I'm just going to change this name to contrast. And oh, it doesn't do an end in Houdini. I never noticed that before. And group. Okay. Then we're going to lay down a remesh. And all the remesh does is it makes it nice. It just remeshes the whole system. There we go. The reason we lay down a remesh node is because we want to get an uneven honeycomb effect. So to get the honeycomb effect, we're going to lay down a divide. In the divide, we're going to hook it up. And then all we're going to do is we're going to say compute dual. And there we go. If we just turn off the remesh node, we're going to see how even that is. It's kind of not really good looking. So if we put down the remesh node, it just evens, well not evens, it unevens them all to make a much more organic feel. Okay, then we're just going to delete the colored effects. So we're going to say delete, to delete, and we're going to say points. Yes, there we go. So we're deleting all the points that have that are in the group to delete. Okay. So now the group's gone. All we're going to have is CD and P. Then I'm going to lay down a connectivity node. Now I'd use a connectivity node to make islands because right now we're not having an island. We're just having this is one island. If I was to go back to my paint shop and draw another one around here, but they were not to connect at any point, that would be an island in itself. Okay. So what I'm going to do is I'm going to change this to primitive. And I'm going to say class ID. There we go. And then I'm just going to lay down a facet node because we want to create unique points. So I'm just going to say facet and then unique points. There. Okay, that's the base section done. So I'm going to put this into a network box. I'm going to change the color to maybe like that. It's not really easy to see. Okay, there we go. I'm going to say this creating start geo. Okay. And then I'm also going to put down a null just to show where I am. So I'm going to say base geo. Highlight the green. Okay. Now, to create this, we're going to debug this system now. We want to make sure that all the polygons in here have roughly 6 points to them. See how this one's just a triangle? This one's got 4 points to it maybe. Let's take a look into the points. Yep, just 4 points. So we want to get rid of those ones as they will, when we extrude our geometry up, they won't look like crystals, they just look like a triangle that's been extruded up. Okay, so we're going to get into a for each loop now. But for this for each loop, we're not going to get into all the specifics, using the name attribute. So we're just going to hook it up, and we're going to turn off the name attribute. Okay, and then we're going to go down to here. We're going to say attribute wrangle, and we're going to lay down and delete sub just for good measure, because that's the entire system we're going to use. Okay, so in my point wrangle, I'm going to then go. I'm going to be going over the points because we want to get the number of points. So I'm going to say actually no, I'm just going to say float point count equals at point num point. There we go. And that's going to get us. It's going to go over each. If we go to single pass, it's going to go over each primitive, and it's going to get the number of points in that primitive. So this one, if we're going to be going on this one, it's going to have 4 points. So I'm then going to say if point count is greater than or equal to 6. Wait, that's not 6, that's 5. As well as point count is less than or equal to 7, then I at cat or category delete equals 0, else I at cat delete equals 1. And what we're doing is we're basically making a different type of. So what's happened here? There we go. Forgot to put in a bracket. And then what we're doing here is we're basically making a different type of group. Whereas if you would right click and select, if you would middle mouse and select this, you will see there's no groups here anymore. However, they have now been given the point attribute of cat delete. And so what we're doing is we're saying every point, every primitive that has either 6 or 7 points to them, you're not going to delete. But anything else, whether it's less than 6 or greater than 7, we're going to put that into the deleting group. So we're going to mark them for deletion. So then all we want to do is we want to go to the delete by expression, and then we want to say at cat delete equals 1. And there we go. We've deleted all the primitives that have those attributes towards them. We still have those attributes there, so I'm just going to lay down one more note. I'm going to say attribute delete, because we don't need them anymore. So I'm going to go into here, I'm going to go to my points, and I'm going to delete my cat delete. Okay, now onto the rest of it. I'm going to say put down another null. I'm not going to put a netbox around this because this is all the for each loops creates its own netbox in a way. I'm going to call this cleaned base geo. Highlight that and turn it to green. Okay. And then I'm going to put down another for each loop. I'm going to go here, and I'm going to turn off the name attribute again because we don't have any name attributes on them. Okay. So we're going to be going over 50 points. Why am I going over 80 and then 50 here? Oh, that's right, because I deleted those. I'm a silly goose. Okay. So then we're going to go, we want to actually make names for these, because right now we can't use the piece name, but we're going to create their own names for it. So I'm going to put down an attribute wrangle. I'm going to change this to primitives. I am then going to say int named. I'm very original with my coding. Detail 1 iteration. And then s at name equals sprintf piece underscore I've forgotten the name of this, %d, and then we're going to say named. Now what this going to do is it's going to go through every piece and name its own different name. Well, if we click it right now, if we just highlight this and go to our geometry spreadsheet and we go to our primitives selection, we're going to see that each one has a name of 0. Because we're not actually getting anything from point 1. So what the detail function here does is it's going to grab from input 1 the iteration value. Input 1 is here. This is input 0. Houdini starts with input 0. To get the iteration though, we're going to highlight the for each begin node, and we're going to say create meta import. We're going to link that meta import up to the first one, and then we're going to highlight for each end, goes back to our geometry spreadsheet and find that they've all been numbered. Okay, so basically they've all been named. So now we can use a for each loop and name them all. Okay, here's some really fun vex we're going to be using now. We're going to create our own custom noise function. So I'm going to lay down an attribute wrangle. I never put down a primitive or a point wrangle, you'll find. I just type, it's easier for me to just go into here and say, change it from points to primitives. So I'm going to say create custom noise. Now, back in my other tutorial, the noise actually threw a lot of errors. Not because of my coding, but just the way the nodes were set up, it didn't like some of the noise functions. I've managed to fix that now, so we're not going to see any errors. Okay, so first of all, we're going to start by selecting primitives, just so we don't forget. Then we're going to say vector frequency equals channel vector frequency, and then we're done. So what I'm doing here is I am laying out custom parameters that I can easily change. I don't have to go in here and put in like 1 or 15. I am now going to be able to just go into here and grab sliders and move them along to create the effect I want. So what I'm doing is I basically like to list them all from what they are. So vectors first, floats next, channel F. You can just do channel, but I like to do channel F just for continuity, and so that it's more verbatim. 10, HF, 10, and then int turb channel I, turb. Okay. Then if we just hit this, there we go. There's all our custom parameters. Now to create the actual noise, we're going to be using all of these. So we're going to say f at noise, although we don't really want to be creating a float in itself. So I'm going to say float, because the difference between what I've done here is the float and the f at something. So let's say noise. F at noise. There's a difference between using the at symbol and using just the float. What the float is doing is it's storing a variable, and the variable is only run in that one node. If we create an attribute, it's going to be run over every single node. So if we highlight this, that's not a good idea. We highlight this one, we're going to see there's attributes in here. And so there's a class ID attribute. So that will be written out as s at class ID. That's how you would write an attribute. To write a variable, we do this. It's better for the memory if we do a variable though. So I'm going to put down float noise equals a noise or alligator noise at p frequency minus the offset turb rough 10. There we go. It's working. Yes, it's working. Then noise at amp, and then we're going to say at CD, because at CD is already a attribute. It doesn't matter. We're going to be over iterating it over anyway. So I'm going to say noise. Done. Okay, nothing's changed. Why hasn't it changed? Well, let's put some parameters into this. I like to do a parameter of 5, 0.5, attenuation of 1, turbulence of 10, frequency, yeah, quite far, but it's not working. Why isn't it working, you might ask? Let's try something different. Let's say float noise again. Doesn't like that. Okay. It should all be working though. Let's take a look. See, we're debugging all of these so that we can make sure that nothing's going wrong. It's correct. It's all correct there. So I'm going to put this back to an F at noise to see if that makes any difference whatsoever. at. It did not. So why isn't it doing any difference? It should be making a difference on here, but it's not. Let me pause this just to figure out what I'm doing wrong. Okay, so I figured it out. It wasn't too hard. The reason why we're not getting anything showing up in here is because we've already set a CD attribute. So what we have to do is we have to delete them. So I'm going to say attribute delete. Some people use a clean. I found that sometimes they throw errors. So I'm going to delete the CD. There we go. Is there anything else I need to delete? No. So I'm just going to leave it like that. So I'm going to say delete CD. And you find we're going to have to do that quite a bit because we set the CD and then we have to take it away. We're going to be using the CD to drive the size and the spacing and everything like that. Okay, so that's the first part done. So I'm then going to, in the same attribute wrangle, I'm also going to do a name system for the islands. So I'm going to say s at name underscore 2 will equal to sprint f island underscore d at class of ID. And now we won't, I don't think we'll need the class ID anymore, but I'm going to keep it just to make sure in case of anything actually no, I'm just going to delete it. Okay. Attribute delete, because we don't need this anymore. It would be nice if we could just delete it up here, but it's probably going to be better this way. So I'm going to get rid of the class ID. Okay, there we go. So we're going to say delete class ID. Okay. And then I'm going to put in another null because this is the end of this point here. So I'm going to say colored pieces. I spell color that way because I'm Australian, by the way, in case you didn't know. Which I don't think you should be able to know unless you saw the sign which said CG Dingo. And where do you get dingoes? Australia. There we go. That's my reasoning behind the whole name. You don't need to look into it that much. Okay, so now we're going to go into our biggest, well, not the biggest, but the hardest point that I had to deal with this exercise. So what we're going to do is we're going to put down a for each loop again. And we're going to put it up there. And instead of going over the names, because we are going to be going over the names, I'm going to be going over the name 2. So if you remember, the name 2, which we just did, is my island. So we're just going to be going over the one island, because I want to do them all at the same time. So then what we're going to do is I'm going to create some custom attributes. For that, I'm going to say attribute wrangle. And I'm going to put this down here. Load that up there. And I'm going to say f at custom z-scale equals to at cd dot r, that's a 4. Okay, and f at custom i-scale at cd dot r. And I've misspelled my scale. Yay, go me. Scale, there we go. Okay. So we don't tend to actually need, I don't even think we even need these custom scales just yet, but they are going to be very useful further down the track, so that's why we make them. So then I'm going to put down a poly extrude. Now, if you don't know what the poly extrude does, it basically just extrudes the primitive. So if I go distance like that, all good. But they're not going, they're all going at the same height, basically, and we want to have more variety in there. And so with the variety, we're going to be using the CD attributes. So I'm going to put this down to primitives because that's what the CDs should be on. And they're not actually doing anything though. Okay. So I'm going to go to the local controller and go custom distance scale. I'm going to say custom Z-scale. And there we go, I've got the difference in height. But they're too close together, so I'm going to say inset scale. Custom I-scale. What's happened? Nothing's happened. So if we got that, you're going to see it's only going to be happening on there. So we're going to have to inset before we do this. Okay, so I'm going to turn off my distance scale. And I'm just going to say, okay, distance 0. And if I push this as far as I can to one side, you're going to see that some of these points are not going to be pushed anymore. these aren't getting pushed anymore, this one's getting quite pushed, but these aren't getting pushed at all, and I want to be able to push them as much as I want. I'm not getting very much control. Okay, so what I'm going to do is I'm going to turn off the custom, that custom there. I'm going to say extrude the front. I'm going to say main X. I'm also going to extrude the side. I'm then going to say my inset, let's do 0.003. This is the distance that I found worked best for me. Other times it might throw some small errors, but that's just nitpicking really. Okay, I believe you'll have to change this with how big the overall things were going to be when they come in as well. Okay, so then what we want to do is I want to group all these and push them down to the point areas. So what I'm going to do is I'm going to say group combine, and I'm going to say main X with main X. Yep. Good. Okay. And then I'm going to say, I don't think we need to do that, actually. I think this is just a redundant null, or node, whatever you want to call these. So I'm going to keep it there. So group promote, I'm going to promote it down to the points. So I'm going to say group promote, main X. I want to keep the original group too, by the way. And I'm going to say from primitives, I'm going to say main X point. Okay, last one. I want to do it to the edges too. So I'm going to say group promote. And I'm going to say from points to edges. And I'm going to scroll down and I'm going to say main X point. I'm going to say keep the original group and only include elements there. I want to rename them. So I'm going to say main X edges, or edge. There we go. And then I'm going to lay down a group rename node, because why not? Well, actually, there's a good reason why I do that. But I'll get into that in a second. So I'm going to say group rename my main X point to, just going to copy that, to main X point, oops, to main X point underscore 2. Okay, on to the really good part. So I'm going to lay down a primitive node. And again, this is the reason why I put down a facet at the end, so to make them all unique. So I'm going to do a transformation, and in here I'm going to say, in my scale, fit 01, because we're fitting between 0 and 1, the $CR, or color red, 0.2, 0.7. Close that, copy that, and I'm just going to paste it into the others as well. And we're going to see that based on the color attribute is going to be how thick they are. So that's what the custom noise does here. So if we just change these, we can't actually change them because we should be going over here. So we go back to here. They're all black. What's happened there? Oh, my attenuation was down. There we go. Okay. It's going to be taking the color value of each primitive, and it's going to scale them by how white they are. Okay, and then we're going to put down a resample node. And I had a lot of issues with the resample node because they weren't working for me. They just made horrible errors. Okay, so I'm going to say a long chord. I'm going to turn off the maximum segments, and that's actually it. I don't need to do anything else. What I've done here is I've changed the numbering system. So, oh, how lucky I managed to pick up that one. So if I go to here, you're going to see that it's going to go 0, 1, 2, 3, 4, 5. So it's not very ordered. What I've done here is I've just ordered them out. So 0, 1, 2, 3, 4, 5. I've made them more ordered. Okay. Now what I want to do is I want to go back down to here. We're not going to be using this one right now, but we're going to delete some points. So we're going to hook this up here. Also, here's a side note. As a side note, you can press Control S, or Shift S, sorry, and you'll get your nodes to be more outlined like that. It's not actually in when you press D, it's not in here at all, which made it quite frustrating for me because I liked it this way. So it took you would not believe how long it took me to figure that out. Okay, I'm going to delete the main x. So I don't want that. I'm going to say delete non-selected too, because I just want these points. Now, I'm going to say point wrangle, because we're going to be doing over the points. And here's the point that is possibly the main driving system behind this. So I'm going to get my pen tool just to illustrate this a lot better. Okay, so when a primitive has an attribute, obviously. So an attribute can be the at, that's not an at, that looks like an at, CD. So at CD is an attribute. But when we have, if you remember previously, we had a cat delete node. So if each point here, here, and here has a cat delete of 1, so cat, I can't write with I can't write with my mouse. So cat delete will equal to 1. Now, what that's going to do is it's basically grouping them or identifying them. When we named it, we identified each primitive, but each point is its own identifier. Now, we're using the same points, we can match up attributes. That's how we do an attribute transfer or a group transfer, is we say, okay, so this one's got point 1, point 2, point 3, okay, and this one over here, this node over here has also got point 1, point 2, point 3. Okay, I'm going to transfer all of those points, all those attributes on that point to this point here. So this point now has an attribute. Well, we can actually copy over the position. So this is what we're going to be doing, is we're going to copy over the position of the points from here, the scaled down points, the custom ones that we use driven from the noise, and we're going to say, okay, these points from the inset, or the poly extruded inset one, we're going to position them at the exact same point by using the same numbering system. Okay, so let's put that into practice. And I'm still on my pen node here, so I'm going to go back to this. Okay, so I'm going to say vector other p will equal to point 1, because we're dragging from the input 1, p, or position, at pt num. Okay, and then I'm going to say at p equals other p. There we go. Now we're not finished yet, because we still want to be able to group. We still want to have the little part here inserted over. So we're going to rename this. We're going to say copy p, and then we're going to group them. So I'm going to say group, and I'm going to say extrude true. Why extrude true? Because that's just what I say. Extrude true. Okay. Pull this down a little bit. Actually, we don't put that up. Put that up here. And then I'm going to put down a merge. And we're basically putting the polygons over the polygons, which isn't what we want. We don't want that. However, because we've moved them now, we are going to be able to move these ones as well. So what I'm going to do is I'm going to put down another point wrangle, or attribute wrangle. AW, there we go. And I'm going to say, using my, see how I did a group rename here? So what I did was I grouped these points. I said, okay, so all those points that were there, just put them over to this side. Put them over to the second group. Okay, so I'm going to say at p point 0, because we're getting it from the input 0, p at pt num plus n points group. Because what we're trying to do is we've got to have to push them up a bit. We're going to have to push the numbers of the points up so to make them match. So n points group 0 main x point 2 brackets close. Ooh, what's happened here, you might say? Okay, well, we have to go over the main point 2. Done. And then we want to delete the second overlay, so we're going to say delete. So we're going to say extrude true. We don't want them anymore. Not needed. Then we're just going to rename. So we're going to say group rename, and I'm going to say, okay, main X to extrude tree. Done. Okay, there you go. All done. Thanks for watching the tutorial, and nah, sorry, only joking. So what we're going to do now is we're going to extrude them up, and to be fair, this part of the tutorial has been done before, but for continuity's sake, I'm going to do this as well with you, just to show you my method. Might have to end up doing a part 2 to this because we're already at the 40-minute mark. I really did not mean to do that. Okay, so I'm going to go through this as fast as I can. So I'm going to say, put down a null again to mark where I've been. Ready for gem extrusion. Yeah. Cut that green. Lay down another primitive wrangle, but we're just going to copy my my custom noise. And then, because we want to iterate over all these little ones here as well, so I'm going to put the frequency right down though. So I don't need it. I'm going to put the amplitude down to 4 too as well. We don't really need them. Put the roughness to 5 maybe. Yep, okay, I'm going to say 1, because see how it's scaling in and out. I'm going to say like 1.5. There we go. Okay. And then I'm just going to do one more thing. I'm going to grab my attribute wrangle here again. So I'm going to get rid of this part here. And I'm going to say f at custom z scale equals the at cd.r. Okay. Now all we have to do is extrude. So I'm going to say delete. Lay down delete node. I'm going to say delete non-selected, and I'm going to say extrude tree. And you might be thinking, why did I bother doing all this then to just delete it, download? This is because that's going to be used later for the smaller gems. What we're doing right now is we're creating the bigger gems. So I'm going to say delete. I'm then going to create my poly extrude. And then I'm going to... sorry about that, I just had an unexpected visitor. Okay, so we're going back into it. We're going to say poly extrude, and we're going to say, let's put a distance of 0.5. 0.5 seems good. I'm also going to extrude the front. I'm going to say FA. I'm also going to go to my local control and say custom Z scale. Let's go custom Z scale. And there we go. Done. And now what we're going to do is we're going to just inset a little bit. So I'm going to say primitive wrangle again. And using my EFA group, I'm just going to say, inset it maybe 0.8 amount. And then I'm just going to clean up everything else. So I'm going to say group delete, as well as attribute delete. So I'm going to put down my attribute first, groups next. Attribute, so what attributes don't I need? I need that one. I need that one. Don't need this one. I don't need these ones anymore, I believe. Let's see. Anything else? I don't need my color either. The colors, we're done with my color. Detailed attributes, nothing. So this is quite clean. So I'm going to say, oh, there's quite a few groups here. However, we don't need them anymore. So I'm going to say, like that. And how many groups have we got? None. No more groups. Cool. Now we're going to delve into a slightly harder for each loop. It's going to be basically the same thing, but we're going to be doing something pretty cool that I haven't actually seen done in a tutorial yet. So normally what you would do is people would make an inset, push it up, and then pull it in a bit to make it look pointy. However, that would only just work for the middle. I don't want to do it on the middle. I want to do it randomly to make it more organic. So I'm going to put down a for each loop. I'm going to go here, drag it out because it's quite big, this one. I'm also going to do another for each loop. I'm going to say this one's going to be for the name too, for the islands. This one's going to be just name. So they can be pretty close. There we go. I am then going to put down an attribute wrangle, and this attribute wrangle is going to make a hash. So I'm going to say wrangle. I'm going to say just do it on the detail. I don't need to do it anymore. Okay, so just do it on the detail. Oh, also, we might want to go up to here and under our extrusion, just say, yes, extrude output the back. So that it actually outputs. Back here. Back to the attribute wrangle. So, now what we do is we say int hash. I'm trying to go as fast as I can now. Random underscore s hash. This is making a hash of a basically of a string. So I'm going to say sprint f. I'm sorry, I'm not saying this because I can't remember the name. Percentage sign. There we go. Percentage sign underscore percentage sign d. Attribute name. Channel I or channel f seed. And so we can actually just change the seed on the fly. So I'm going to say f ash, not hash. I like ash. It's better. I've got some lovely friends called Asher. And random hash. And we can change the seed that way. Okay. So then what we're going to do is we're going to lay down a subdivide. The reason I'm going to put down a subdivide but not actually do anything with it is because we want to reorder the numbers again. We can easily do that with a simple resample, you might say, but this one's simpler because it makes it more easier to work with. So I'm going to turn off my recompute point normals because I don't need them. I'm also going to go to open subdiv by linear. This is a different algorithm and it numbers them differently. So if we check it out, they are numbering them differently. Okay. Then I'm going to say group. Say group. So it's not numbering the points, I don't believe. It should be numbering them differently though. So if I go back to here, see how it's given them more points here. So if I just go back to my numbers, that's right. There we go. That's why I wasn't seeing it. Okay, so if I go to my subdivide and I go here, you're going to see this is going to be like number 13 or something like that. I want the number 1, the most easiest point to remember, here. This is also going to be point 0 down the bottom. Okay, so then I'm going to say group. I want to group the point. So I'm going to say group point, and I'm just going to say 1. I just want to group the top one. That's why we did that different subdiv. Okay. Now what we're going to do is we're going to say group, another group. And if we check it out, when we did the extrude, they should be numbered 1 as well. So I'm going to say 1. Just grab that 1. Now I'm going to put down a scatter node. And I'm going to say scatter 1 point over the group. Why is it just called group 3? So I'm going to rename this to maybe scatter group. And rename the scatter group. There. So it's only going to be scattering over that point. To make it more organic and more different, because sometimes they don't work, I'm just going to say get my detail. So I'm going to say detail op input path 0. Oops, 0. Let me just check out my code for this. That's right. 0 ash 0. And that's going to get the... Oh, it's not working. I must have done something wrong here. That's right, I didn't put down a 0. There we go. And that's going to use the attribute that we've made based on the name of the point, of the primitive that we're working on. Okay, so that's going to scatter that way. And now I want to move this point to that point. So we're going to use the same method we did up here. So what we're going to do is we're going to go to my make an attribute wrangle. I'm going to say move point. Grab this, put it there. And then I'm going to say at p will equal to point 1 p at pt. There we go. Done. That's it. That's all we needed to do. But it's not working. It's not working how it should do. I'm not too sure why. Oh yes, that's right. Because we're grouping every single point on there. So all we want to do is we want to run over the group point. There we go. So we've basically moved it. There we go. Okay. Now I want to extrude by the normal, and you can easily just do this. So I'm going to say at P equals at P plus at N, actually no, brackets at N times by channel float, not float, by amount. It still doesn't like that because we need to put another bracket in there. And then see what the only difficulty is that you've done this. So if I go to here and I say, okay, 1, see how it's extruding up that 1 point, but it's making all these points bad. We can put down another node, but it's just there's no point in doing that. So I'm going to turn that off. Also going to go to my parameters, and I'm going to say delete, accept. There we go, just to make it more clear. Okay. Now I'm just going to put down my attribute vault. This is the only time I use an attribute vault, by the way. I'm going to say, okay, just group this one. What have I done here? I must have hit enter or something. Then I'm going to go into here. I'm going to say displace along normal. Grab that. I'm going to put in the P here. I'm going to put in the normal here. I'm also going to just chuck in here to the P, the position to the P, and then I'm going to say the amount. I'm going to say promote parameter. If we go up here, I can then promote that parameter. So I'm going to put this about 0.5. Okay, so should that work? Yeah, it's working. It's working. So you can stop there, and it does look like a gem system. Does look pretty good. But what you could also do is you could subdivide them. However, when you subdivide them, you don't want the bottom points to subdivide with them. So how we do that is we put down another group, and we're going to say, okay, not group that. We're going to say base group. And in this base group, we want to just select the 0. So it's going to select the 0 of every primitive. Then we're going to say bound. Put down a bounding box. Yep, I'm going to say group by that one only. And then I'm going to say maybe 0.5. Too much. Okay, 0.05. So I'm just going to copy that, chuck it in there. Maybe it's a bit much, so what I tend to do is I tend to copy the parameters and paste them all into there so that I can just mess around with one of them and nothing happens. You know, it works properly. It's how it should. So I'm going to maybe put this down to 0.1 like that. And then what I'm going to do is I'm going to put down a poly reduce. And the reason I do a poly reduce is it gives it a bit more organicity. So I'm going to put it in here, and it's done nothing. So I'm going to put this down to maybe 25. I've put down 25 in my numbers because it gives it a much more harder look to it. And then I'm going to group what I've done with the bound here. So I'm going to say group, chuck that into there. You can press Alt and highlight these and move them down to make it more workflow better at least. I'm going to say base group, and I'm going to say get the points, turn off that, keep in bounding regions, box only. There we go. But we need to promote them up. So I'm going to say group promote, because we can't just, when we put down a subdivider, it's not going to work, because they don't work on points, they work on polygons. So I'm going to say group promote, go to here, and I'm going to say from points to primitives, then I'm going to say base group. It's going to select everything there, so I'm going to say include only elements that were there. Okay, and then I'm going to say group combine, because I want to invert that group selection. So I'm going to go to here, I'm going to say base group equals all base group equals all but. Okay, then we're going to lay down a subdivide. This is just personal preference to me. I do like looking at them this way. See how what it's done is it's put the points up there. So I'm just going to say group by the base group. There we go. Cool. And then I can say override that and make it harsher so it's not as bad, or you can use a different method as well so it doesn't do such a harsh look to it. It has no difference on it whatsoever. Okay. I did actually just use the Houdini one here, and I put like a value of like 0.9 or something. 9.3. Made it like a linear crease, so it's much more. You got more to work with here, I suppose. Okay, I'm going to put that at 0.9, and we're pretty much done for the main crystals group. Because we're hitting an hour already, I think I may stop. But before we do that, I'm going to do some last minute house cleaning of this. So it all works, right? All works pretty well. I prefer not to have the subdivide on, actually. That was just something I did for a personal project of mine. So it all works perfectly well. They're heightened by the amount that we've given. So we've got small ones, skinny ones, fatter ones. Okay, I'm going to put it down another for each loop because I want to rename all of my stuff so that it's easier when we want to. Whoops. It's easier when we want. What's happened here? It's easier when we want to bring them into something like Maya. I'm also going to pack them, but that's going to be later down on the track. So what I'm going to do is I'm going to say attribute wrangle here because we're going to be dealing with a lot of different ones. They're all going to have the same name, unfortunately. So I'm going to rename them all. There's one unique. Why is there only one unique? Should be more unique. Yep, I'm just going to use the name of this one, and I'm going to say in my attribute wrangle, let's go over the primitives. S at name equals large gems underscore plus S at name. Done. Okay, that's all it was. So I'm just going to say rename. Oh, my spelling is atrocious today. I'm then going to do some cleaning, so I'm going to say attribute delete. That's not a delete, that's a wrangle. Attribute delete. And a group delete. Okay, so my attribute wrangle, I'm going to delete my PT. Don't need that anymore. My ash. My name is going to be staying on there though, but I don't know why we have a detail for the name, so I'm just going to delete that as well. And then we're going to keep. We don't need the name 2 anymore actually, because we're making a new name. So I'm going to say. Actually no. Large gems plus at name s name, and then I'm going to say plus underscore, and then plus s at name underscore 2. So we're going to get a better naming system. So if we go into here, we're going to see what they look like. So name, it comes from there. I'm actually going to put the name at the front actually. So here plus underscore plus that. I'm going to put it there just to make it a little bit easier to read. So island 0, large gems, piece 49. That's going to wrap it all up into one lovely detail basically. And then I'm going to do a group delete, and we've got a few groups that we don't need, so I'm just going to say delete all of them. And then if we just grab this, we're going to see we've got 50 unique names. Oh, we didn't delete that one. Okay, so I'm going to say name 2. Don't need that anymore. And we're pretty much done for the large gems. Okay, so I'll just go to my spreadsheet, and we're going to see they're all uniquely named. We could pack them, but I prefer not to because it does actually slow down the system. Don't know why, but it does. They're supposed to be faster, but because each... I think the reason is because each one of these is different. When you use packed SOP, it helps if they're all the same piece, which makes it run a lot faster. But let's just test this out. So I'm going to go back up to my paint SOP, and I've only selected that one, so I'm going to say turn it off. Go here. I'm going to reset it all. I'm going to put down maybe my let's put down a C D. Okay, that should work. We go here. Yep, it's working. Yep, it's working. Yep, it worked. Now, there's not many of them, which is a bummer, but to remedy that, I would say, you would just go up to here and put in more for the geometry, or you can even lay down a subdivide down here. So I could say subdivide, so see what happens there. It might just break the system. I'm not too sure, I haven't tried it. It kind of did break the system. So I'm going to go back, I'm going to grab this, put it up here maybe. Maybe that works down there. So we've got a subdivide, there's that, remesh. Does the remesh know that it's actually having that in there? Yes. Okay, so I'm just going to say, maybe make it like this. Like that. Or we can just try, we're just trying different ones really. Yeah, just trying different ones. See if that does anything down here. It's made some more. So you can just put down a subdivide. Or you could just up the amount of polygons to start out with, really. So I'm just going to get rid of that subdivide. See how it just instantly changes. That's what I love about Houdini. You can make one change and it will just cascade all the way down. Okay, so that's the first part. That's part one. The large gems. I hope you really enjoyed this tutorial. I'm going to the second one's going to be dropped pretty much instantly at the same time, because I'm not going to stop recording this. But I really hope you enjoyed this, and if you have any feedback, I would love to hear from you. You can also message me on Facebook or on my website, which is at cgdingo.com, although it's not, as of recording, this is actually not set up properly still. But yes, I'm also going to be leaving this file to be downloaded and for you to just go through as well, to see what I've done, to see what you might be able to do to make changes, make it better. I'd love to see what you could do to make it better. Not that I'm challenging anyone to say, oh, you can do better than me, but just play around with it, see what you can use this for. Make it into an OTL maybe. Sell it online. Well, maybe not sell it. I would like some of that revenue. I'm a poor artist. Okay. Thanks for watching, and I look forward to seeing you in the second part of this tutorial.